Good morning, everyone. Today we are going to focus on the project management. Projects are special type of transformation process. If you remember, the first chapter that we have already discussed a long times ago, we have already talking about the form of the system. The project is quite similar to the job shop production system, but in terms of the size, the project, the product of the project is big, is huge, but actually it is more or less the same as the product of the project is more or less the same as the product of that was produced by the job shop, because it is one of a kind product. And in order to manage the project, since we have large number of activities and some activity have to be done concurrently, so we need some basic idea in order to coordinate this activity efficiently. So this is the example of the projects, like if you build a bridge or highway or a building, a home, even you organize a conference, this is some form of the project that you could use this management technique in order to deal with it. In order to manage the project, we got one person, because in one project there are so many members, okay, in a team. But one person that is very important to manage the team, we call him project manager. He is the head of the project team, and his responsibility is to communicate and coordinate with the project team member. He must have the expertise in terms of project management and in terms of the thing that he has to deal with. For instance, suppose we are talking about the building. So normally the project manager is the civil engineer. So he has to know about the construction, he has to know about the material, things like that, okay, and then he has the experience, he must have the experience of building that kind of construction before. And since the project consists of a lot of diverse activities, and some activity have their precedent relationship, okay, this is very important, precedent relationship, since it has to be start after some activity has to be start after others finish. That is the precedent relationship. We have already learned about the precedent relationship several times, okay, and we have a limited time of the project as well, since the project has to be complete within a specific time. So we need to deal with it, we need to manage the project to be complete within that limited time. And the method that we are going to focus today is the critical path method, or we normally call it CPM, okay. In CPM we have to construct a network diagram, or sometimes we call it arrow diagram. In order to draw the arrow diagram, we need to use several graphical representation. The first one we call it arcs, okay, arcs, this one, okay, arcs, you can draw it as a straight line also, whatever, okay. Arcs represent activities, okay, one of the project operation tasks, okay. Each task or each activity require resource and some amount of time to complete. And the arrow, this is the arrow, okay, the arrow, you have the head of the arrow here, okay. represent the precedent relationship between activity. Okay, and node this one node represent the start or completion time. Okay, start or completion of an activity. This one node, right? And the network. Okay, when we combine our arcs, our arrow and node all together, and then the final graphical representation of the project, we call it a network. Okay, all the project activity graphically interrelate through the precedent relationship, like this one. This is the one of the network diagram or the arrow diagram, right? Okay, so the path is the series of connected activity from start to finish. I give you some example. This is a start node, right? This is the end node. Path, okay, series of activity. For instance, A, D, J is one path. Start from the starting point, connected to several activity, and then end at the end node. Again here, B, G, I could be another part, or B, E, J could be another part. There will be several parts in the network, right? And one of the part that is very important to the project management, we call it critical part, which is the longest part of the network. Meaning that if this part is delayed, all the project completion time will be delayed. The entire project will be delayed. And the critical activity are the activity on the critical part. I will show you later about critical part and the critical activity. And in order to use CPM to manage the project, you need to have the input information about activity, duration, and activity precedent relationship. For instance, show you this one. Okay, this is the example. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 activity, and each activity has the time corresponding to it. Okay, for instance, activity A need 10, let's say, days to complete. B need 10 days. C need 5 days. And each activity may have the precedent or the preceding activity, like D. Before you can start D, you need to complete A first. Or before you can start E, you need to complete both B and C, like that. Okay, this is the input information. And the output information that you will have from using CPM, that is the graphical representation of the project, and the project completion time or project finish time, and the critical part and critical activity, and the last one is slack time, right? Okay, these are the information that you need to calculate today. And in one other thing that you have to be aware of, that is the dummy activity. For dummy activity, okay, here we have two nodes, right? This is the first node, this is the second node. You cannot draw arcs that start from the same node and end at the same node. Okay, this one not allowed. But what you have to do is you can change to this one. Okay, node activity A and B, like this. You can change it to A and B with a dummy activity. Dummy activity is the artificial activity, right? So normally we use the dotted arrow like this one, and the dummy activity has 0 time unit, so no meaning at all. But you have to use it in order to represent this one, because this one cannot be used. Okay, so you can use this one or this one, put dummy here, or put dummy here, or put dummy here. right? Okay, you have several choices. It's up to you. But sometimes you need to think about where to put the dummy. Okay, because sometimes it's not correct, but sometimes normally it's correct, but sometimes it's not correct. So another thing that is very useful for the dummy activity is that this activity could be used to show the precedent relationship that cannot be represented in an ordinary manner, meaning that you can in sometimes you cannot represent in the normal way, so you have to use it to help you to represent the relationship like that, right? Okay, I will show you later. For instance, suppose we are looking at this example, today example, which is a little bit complex, so please pay attention to this exercise. Okay, I will draw the arrow. First, I will draw the arrow diagram for you. First, you have to put on the start node here. I will go slowly. Start, right? Then go to the table, find the activity that come without precedent relationship. So in this case, A, B, and C. Okay, A, B, and C. So this activity will be connected to the start node, A, B, and C, right? A require 10 days, B require 10 days, and C require 5 days. You put name of the activity and the duration of the activity in parentheses, and this is the arrow. Okay, A, B, and C. Then finish here. Start D. D can be start after A finish. D start after A finish. If you want one activity to be start or to be finished, you put the note on here. Okay, A start here, and if you want it to be end, put the note end note, because note represents starting point or ending point of the activity. So A ended here. Then D can start. D requires 7 days, right? D requires 7 days. E require B and C. F require B and C. G require B and C. B, E, F, and G, right? So normally you can put like this, B and C connected like that, right? But this is not allowable, this is not acceptable, as I told you, like this one. Okay, this representation is not allowed, so you need to change. Okay, so in this case you put the dummy here. This is the dummy. B, C, put the dummy here, right? Okay, and E after B and C. C complete here, but you use the dummy activity to draw this, to continue the relationship B and C, E, right? B and C, F, B and C, G. Okay, E require 5 days, F require 7 days, G require 2 days here. E, F, and G. And then H require 5 days, but F to be complete after C complete. F to be complete after C complete. Sorry, H to be complete after C. H, not F. H. Yes. C finish here, right? H start after C. This H require 5 days. And then I require G and H. G here, H here, right? Okay, so you pull them together to one node. Then okay, G and H, you can put I here. require 8 days, and J require 4 days, but D and E have to be finished. D, E, right? Combine together in one node here, and then J. Normally you will got the loose end, okay, loose arrow, and then no more, right? No more activity. So you pull them together to the end node here, right? Okay, so this is the arrow diagram that you have to draw, right? I think you can understand it. Okay, this I have already told you. Okay, now you need to find the earliest start time of each node. So in order to find the earliest start time of each node, right? So you put the cross symbol to all the node, like this one. Okay, this is the arrow diagram that you have to do it earlier, and then put cross on all the node, right? And for the start node, earliest start time for the start node is equal to 0, right? Okay, and then you move forward. When we are talking about move forward, it means that we move from left to right hand side of the arrow diagram. So you need to find TE of the next node. Okay, TE. You know TE here. Then TE1 plus time on the activity, on this activity, you get TF1. Okay, TE2 is equal to TF1. This one. If you have just only one arrow go into this node, but if you have more than one arrow go into the same node, like this one, you need to find the maximum of TF. You have to first compute TF1 and then TF2, then find the maximum of these two. Okay, TE3 is equal to maximum of TF1 and TF2. Alright, so I will show you. First, move forward. Move forward means moving from left hand side to the right hand side of the arrow diagram. So first, starting from the start node, put 0 time to the first node here. Then 0 plus 10 is 10, because just only one arrow go to this node, so put 10 here. 10 plus 7 is 17, but we got 2 nodes here, so we have to wait. 0 plus 10 is 10, wait. 0 plus 5 is 5. We got just only one arrow, so put 5 here. 5 plus 0 is 5. 10 plus 5 is maximum is 10, put 10 here. 10 plus 5 is 15, so you got all the arrow here. Okay, all TF. 17 and 15, the maximum is 17. 17 plus 4 is 21, right? But you have to find 2 more. 10 plus 7 is 17. 10 plus 2 is 12. Wait. 5 plus 5 is 10. So these two together, use maximum, is 12. 12 plus 8 is 20. Then you got all of the arrow, okay, all of the TF, right, coming to this node, that is the end node. 21, 17, and 20. The maximum is 21. This number TE at the end node will represent the project completion time. Okay, this one. So you can answer when will project finish. You have to say that 21 day. Alright, okay, this is the project completion time. Right, okay. Then after you finish the forward, okay, calculation, then you need to do the backward calculation, okay, in order to find the critical path, critical activity, and slack time of each node of each activity. So you need to find TL, latest start time. For the latest start time of the end node will be equal to earliest start time of the end node, right? Okay, you TE put equal to TL at the end node, and then you move backward, meaning that you have to go back from right to left hand side of the network diagram. You know TL2 minus T, you get TS2, because just only one arrow come out of this node, so TS2 is equal to TL1, right? Okay, one arrow come out. But if there are more than one arrow like this one, you need to use the minimum value, minimum, okay, forward max, backward min. So in this case, minimum of TS2 and TST, you got TL1 here, right? Okay, so here you got 21 here, right? Because this is the end node, so you put 21 here, and then starting from the end node, you move backward to the start node. 21 minus 4, you got 17, and since you got just only one arrow come out of this node, you put 17 here. 17 minus 7 is equal to 10. One arrow, you put 10 here. 10 minus 10 is equal to 0, but there will be two more that you need to calculate. 21 plus minus 7 is 14. Wait. 17 minus 5 is 12. Wait for this one. 21 minus 8 is 13, but just only one arrow, you put 13 here. 13 minus 2, you got 11. All these three arrow, okay, TS, earliest start time. Okay, so this one, minimum of this one, these three, you got 11. 11 minus 10 is 1. 11 minus 0 is still 11 because dummy node, dummy activity, okay, dummy activity has 0 time unit. 13 minus 5 is 8. Minimum of 11 and 8 is 8. 8 minus 5 is 3. So the minimum of these three is 0. Right? Okay. So you must know that after you do the forward calculation and backward calculation, at the start node you need to have 0 and 0. If not, meaning that your calculation is wrong. Okay, you need to find some problem inside your calculation. So here is the complete. Then once you complete the finding the number on the cross symbol, then you could be able to find the critical path and critical activity by first you circle the node, the cross that has TE equal to TL, right? TE equal to TL. You circle it. That is the tentative node for considering on the critical path. It could be critical activity or could not be. Okay, it depends. If it is the critical activity, it will have this relation. This one, the number on this one plus this will be equal to this number, or this number, okay, minus this one equal to this one. Normally we use plus, right? Okay, so in this case, first you circle the tentative node here, 10 10, right, 17 17, 21 21, right, circle. And then if this one plus the duration on the arcs equal to the time here, that will be the critical activity. 0 plus 10 is 10, so activity A is critical activity. 10 plus 7 is 17, so activity D is the critical activity. And then 17 plus 4 is 21, right? So again, activity J is critical activity. So we have three critical activity, that is A, D, and J. So here, critical activity, okay, this one, A, D, J, A, D, J. And then once you got the critical activity, and you need to draw a part that composed of all critical activity, that will be considered as the critical part. So because we have just only one part here, that is A, D, J, right? A and then D and then J. We use the arrow to represent the precedent relationship of the part. This is A, D, J, is the critical part, which consists of critical activity of A, D, and J. And project completion time is equal to 21. Come from where? Come from this one, right? This is the project completion time. Okay? And then if you want to find the slack time, the simple way to find the slack time is using this diagram. You find the TL2. Okay, first TL2. If you want to find the slack time for this activity, TL2 minus TE1 minus T, you got the slack time. The slack time meaning the time that are remaining before that activity will be delayed to the project, will cause the project delay. Okay, here I will show you. Suppose you want to find the slack time of activity D. 17 minus 10 minus 7 is equal to 0, right? Okay, again, on the critical part, activity on the critical part, 10 minus 0 minus 10 is equal to 0. 21 minus 17 minus 4 is equal to 0. You can see that for the critical activity, the slack time will always be equal to 0. Apart from that, okay, for instance, suppose you want to find slack time of B. 11 minus 0 minus 10. 11 minus 0 minus 10. You got one slack time, right? You have 1 day. Again here, show you. G. 13 minus 10 minus 2. So you got another 1 day for G. What about I? 21 minus 12 minus 8. That is 1 day. What about H? 13 minus 5 minus 5, right? Okay, that is 3. Okay, very simple. Look, look at from the diagram, you can easily find the slack time. Okay, and then this is the summary of the slack time here. You don't have to do in the table because it's much easier if you do it from the arrow diagram here, right? Okay, so I hope you understand it. And then your assignment today is a little bit complex. We got activity like 1, 2, 3, 4, 5, 6, 7 activity, and their duration, and this is the preceding activity. And the question asked you to find the network diagram is a little bit complex. And then from the network diagram, you need to find the critical path, critical activity, and slack of all activity. There will be quite a number of the dummy activity here, and a little bit complex relationship. So hope you enjoy this exercise. Okay, thank you and see you next week.